So what we are going to look at today is one more example for the divide and conquer technique, which is about counting the number of inversions in an array. So an inversion is a pair of elements which occur in decreasing order or reverse order in an array. So note that we're talking only about one pair of elements. The whole array, it might be sorted, unsorted, whatever. There is a particular pair of elements which occurs in the reverse order, we call that an inversion. So to look at the formal definition, an inversion in an array is a pair of elements, array of I and array of j, I and j being the indices, such that I less than j. So I is the index which comes first and j comes later, and array of I greater than array of j. So the number which occurs first in the array is greater, and the number which comes later in the array is smaller in comparison to the previous one. Any such pair of elements is called an inversion. So for instance, if you take this array 1, 3, 4, 2, then 3, 2 is an inverted pair and 4, 2 is an inverted pair. So that is what we mean by inversion in an array. So the problem we are given with is to count the number of inversions or number of inverted pairs in an array of integers. Now the most naive, simplest brute force way of doing this would be using two for loops or two loops which iterate through the elements of the array. You pick up every pair of elements and you see whether they are an inversion or not. But obviously whenever we have two loops, it is order of n squared, and for simple problems like this we want to do better than n squared. And in the context of this discussion, we hopefully want to do better than n square using divide and conquer. So that is what we are going to look at in this segment. So that was the premise, that was the question given to us. We will first look at the logic, the algorithm, and then a little bit of explanation and an example. So if you look at the picture to the left, this is the algorithm for counting inversions using divide and conquer. This algorithm is very similar to your merge sort. So merge sort again is another algorithm which uses divide and conquer. Every algorithm which uses divide and conquer has three steps: divide, conquer, combine. And if you look at this one, the divide and conquer steps are exactly the same as merge sort. So you divide the array into two halves, left half and right half. That is your divide step. The conquer step, your base case again is you have an array with just one element, an array of unit size, and you return that element as such. That is what you do in the conquer step. Those two are exact same. The combine step is also very similar. You again have two pointers. You put one pointer at the beginning of the left array, one pointer at the beginning of the right array, and you do a linear traversal. You are also going to be sorting the array as you do the traversal, just as you do in merge sort. There is just one extra step in the combine portion, which is you will first use two pointers as in merge sort. Let's call the two pointers LPTR and RPTR. LPTR is used obviously for the left array and RPTR for the right array. They are initialized at the first elements respectively. Now you will again compare the two elements which the pointers are located at. If the left array's element is smaller, you will simply put that in your final sorted array and you will advance that pointer by one step. As usual, exactly what you do in merge sort. However, if your right array's element happens to be smaller, then there is a small catch. So what you will do is, you will count how many elements are remaining in the left array. I repeat, you have two pointers. One is pointing somewhere at the left array, one is pointing somewhere at the right array. You compare those two elements. If the left element is smaller than the right element, you just put the left element in your sorted array, move the left pointer one step forward. If your right element happens to be the smaller of the two, you will count how many elements are remaining in the left array. And by remaining, I mean starting from the element at the pointer till the end of the array. You will count how many elements are left and you will add that number to the number of inversions. I'll tell you why. So you'll add that, and then again you'll take this right element which you compared and the element which is located at the right pointer, you will put it in the array and you will proceed. You will repeat this step until all elements at both ends in both subarrays have been covered. So I will first explain what I mean by calculating the number of elements and adding that to the inversion. I'll explain why that is done. Then we will look at one proper example of the combine step. Then I think things will make more sense. So now assume you've done some part of the question and you are at a stage where these are the two subarrays you have. Look at the picture on the right. So you have two subarrays. 1, 3, 5, 10 is your left subarray. 2, 6, 8, 9 is your right subarray. And both of them, as you can see, are individually sorted. Now you will start by placing your left pointer at 1, right pointer at 2, as is usually done in your merge sort combine step. Compare both. The left element is the smaller, so you will simply put that 1 here in your answer array, and you will move the left pointer one step further. The right pointer remains untouched. So far so good. This is exactly what we did in merge sort. Now again you compare your left and right. This time the right element happens to be the smaller one. Now what you will do is, and also note that so far the number of inversions is 0. You initialize the number of inversions as 0 and you have not manipulated that variable at all yet. So the number of inversions is 0 currently. Now you check this left and right. The right happens to be smaller. So what you will do is you will count how many elements are remaining in the left array. So 1 has already been taken care of. 3, 5 and 10. So starting from this pointer till the end you have 3 elements. So you will add 3 to the number of inversions. So it was initially a 0, you added a 3. So the number of inversions now becomes a 3. And then you take this 2, you put it here. This pointer now points to the 6. Now again you will compare and you will go on. So that is how it works. We'll see a full step-by-step thing shortly, but that's the basic overview. Now before going into the example, why do we do that? So when you compare the left and right and the left is greater than the right, you notice that it is an inversion, right? So if 3 comes, so as of now you see that I comes first and j comes later, but the element at I happens to be greater than the element at j. So that is how we had defined an inversion. So although these two arrays are not combined yet, if you look at them in this order, 3, 2 is an inversion. And if you see now, because this individual array has been sorted, if this element is greater than 2, anything within this array which follows this particular element is also going to be greater than 2. I hope you guys get what I mean. So you have this left pointer and the right pointer. You know that the left array is individually sorted, the right array is individually sorted. So if a specific element of the left array happens to be greater than this number here, then everything after that element on the left array is also going to be greater than that number. So if 3, 2 is an inversion, then 5, 2 will also be an inversion, 10, 2 will also be an inversion. So if you have 3 numbers here, there are going to be 3 inverted pairs, which is why instead of checking each pair, now that you know 3, 2 is an inversion, you don't have to check 5, 2, you don't have to check 10, 2, because you know this left part is sorted, so obviously they are also going to be inversions. So you simply count how many elements are here and you put that, you add that to the number of inversions and you proceed at every step. So we will look at one full-fledged example of the combined step. I have taken the exact same array which we saw in the previous slide. So your left part is 1, 3, 5, 10, your right part is 2, 6, 8, 9. I am going to combine these two arrays using your merge sort technique while also counting the number of inversions using the method I just described in the previous step. I am going to do it from the beginning till the end. So starting as usual, you have 2 pointers. Left one points to this 1, the right pointer points to this 2. You compare the left and right elements. Left element is the smaller, so you will simply put that in your sorted array. You move this left pointer one step forward, no other manipulation required. Now this is what your array looks like. 1, 3, 5, 10, left is pointing to 3, 2, 6, 8, 9, right is pointing still to 2. Compare your left and right, you see that the right one happens to be the smaller. So you will count how many numbers are here. There are 3 numbers. So the number of inversions is incremented by 3. Then as usual you take this smaller number, you put it in your answer array, you advance this pointer one step. Now if you look at it, your array looks like this: 1, 3, 5, 10. Your left pointer is still at 3 and your right pointer will now be at 6. I am sorry, I forgot to draw the pointer there. Your right pointer will now be at 6. Moving on, again you compare between the 3 and the 6. The left number 3 happens to be smaller, so you will simply put that in your answer array. You will advance the left pointer by one step. No manipulation is done on the variable called I and b. Again, this is a 5, this is a 6. Compare, 5 is smaller, simply add and move the left pointer one step. Now your left pointer is at the 10, your right pointer is at the 6. You compare, your right element happens to be smaller. So you will see how many elements are remaining in this array. Only one element is remaining. So your inversions plus equal to 1, because 10, 6 is an inversion. And there is no other following element in the left array, so it's just a 1 increment. Then you put 6 in your sorted array. This pointer moves to point to 8. Your left is still here, the right pointer is now pointing towards 8. Again compare, you see that the right element is smaller. So again count how many numbers are remaining in this array. Again there's only one element, so inversions plus equal to 1, and the right pointer now moves to a 9. Yeah. So we are now at the final step. Left pointer is at 10, right pointer is at 9. Again compare, you see right is the smaller one. Count the number of elements remaining in the left array. There's only one remaining, so inversions plus equal to 1. You add this 9. Now the right array has been fully completed. There's only one element remaining in the left array, so you'll obviously put that. Here is your sorted array, but then the sorted array is not we wanted. We wanted the number of inversions. So if you count the number of inversions, it would have been 6. If you look at the increments we did. So we first incremented it by 3 and then 1 and 1 and 1. So your final answer is going to be 6 inversions. And if you take a pen and paper or something and trace the number of inversions manually, you will see that these are the inversions: 3, 2, 5, 2, 10, 2, 10, 6, 10, 8, 10, 9. So there are 6 inversions and the number of inversions we got is 6. So this is how we calculate the number of inversions using divide and conquer.